Groningen, Netherlands, February 1945. Canadian forces were fighting through some of the fiercest urban battles of the campaign. The war is almost over, but nobody has told the Germans. In scenes repeated across the northern Netherlands, Canadian infantrymen crouch behind crumbled brick walls, pinned down by German defenders firing from the upper floors of battered buildings. Every movement risks another burst of fire. Advances stall. Every street must be fought for. Then they hear it. An engine. The grinding, familiar rumble of steel tracks on broken cobblestone. During one such engagement, a tank rolls into the street behind them. Low, broad, unmistakably a Sherman. The Germans in the upper floors shift their attention. They've handled Shermans before. They know what a Sherman can do, and more importantly, they know what it can't do. A standard 75mm round fired at a second-story window is imprecise, slow and telegraphed. A sniper team can simply move. But this Sherman is not standard. The turret, massive, angular, bristling with not one barrel but 4, begins to rotate. It doesn't grind. It doesn't labor. It spins, swinging with hydraulic precision at a speed no tank turret has any right to move at. The 4 barrels depress almost flat, locking onto the windows where the muzzle flashes had been. What happens next takes less than 3 seconds. 4 20mm Polsten cannons open fire simultaneously, at a combined cyclic rate of roughly 1,800 rounds per minute. High-explosive incendiary tracer rounds, designed to shred aircraft fuselages at altitude, tear through brick, timber, and reinforced concrete like paper. The upper floors of 2 buildings simply cease to exist in a storm of fire, smoke, and pulverized stone. The Canadian infantry stare in silence. This tank was never built to kill infantry. It was never built to level buildings or silence snipers, or turn a stalled advance into a rout. Canada built it to kill airplanes. To understand why Canada built one of the most unusual armoured fighting vehicles of the Second World War, you have to go back 2 years and look up. It is the summer of 1943. The Canadian Army, hardened after the disaster at Dieppe and now grinding through the campaigns of Sicily and mainland Italy, is learning brutal lessons about combined arms warfare in the modern age. One of the most lethal threats they face isn't a Tiger tank on the horizon or an 88mm gun dug into a hillside. It's a single-engine aircraft screaming in at treetop height with its guns blazing before anyone can react. The Luftwaffe's ground attack pilots, flying Focke-Wulf 190s and Junkers Ju-87 Stukas, had turned low-level strafing into a precise, terrifying art form. A formation of infantry on a road, a column of supply trucks, a forward command post. These were gifts to a skilled Luftwaffe pilot. He could be on target, guns firing and pulling away before anti-aircraft crews even had time to traverse their weapons. In the time it took a gunner to crank his elevation wheel, the plane was already gone, and the carnage was already done. The Allied answer to this threat was, by 1943, deeply inadequate. The workhorse of Allied mobile anti-aircraft defense was the M16 multiple-gun motor carriage, a half-track mounting 4 50-caliber Browning machine guns in a powered turret. Popularly known as the meat chopper, the M16 was better than nothing. Against slow, low-flying aircraft, it could put up an impressive wall of lead, but it carried 2 fundamental, potentially fatal flaws. First, the 50-caliber round, while effective against unarmored aircraft skins, lacked the explosive punch to reliably destroy a fast, armored ground attack plane in the brief seconds it was in range. A pilot hit by 50 cal fire might still complete his attack run before going down. The damage was done either way. Second, and more critically for the crews operating these vehicles, the M16 was completely open-topped. The gunners sat exposed to the sky, to shrapnel, to small arms fire, to the very strafing runs they were supposed to prevent. In the brutal, fluid fighting of the Italian campaign and the coming campaign in northwest Europe, this was not a minor inconvenience. It was a death sentence. Anti-aircraft crews working in the open were being killed, not by aircraft, but by the German artillery and mortars that had learned to target the distinctive silhouette of the half-track the moment its guns opened up. The Canadian Army Technical Development Board, a group of engineers and military planners tasked with solving exactly these kinds of problems, took a long, hard look at the situation in 1943 and came to a clear conclusion. What the Canadians needed was something no Allied nation had yet produced: a purpose-built, fully enclosed, heavily armoured anti-aircraft fighting vehicle. Not a half-track with a gun bolted on, Not a truck with a machine gun in the bed. A proper tank, one that could survive the same battlefield conditions as the infantry it protected, drive forward with the advancing line, absorb small arms fire and near-miss artillery, and still put enough firepower into the sky to turn an attacking aircraft into wreckage. The weapon they envisioned was something entirely new, something with enough guns firing fast enough to guarantee destruction in the seconds-long firing window a crossing aircraft provided. Something with armor thick enough that its crew wouldn't need to pray every time an artillery shell landed nearby. Something fully tracked, fully enclosed, and capable of keeping pace with an armored advance. They gave the project a name drawn from the natural world of their home province. Small, fast, almost impossibly rare. They called it the Skink, and to build it they turned to the industrial heartland of Canada, the furnaces, the foundries, and the factory floors of Hamilton and Montreal, where some of the most capable engineers on the continent were about to attempt something that had never been done before. The steel that would become the Skink was first poured in Hamilton, Ontario. Hamilton in 1943 was not a quiet city. It was a city on fire, not from bombs, but from industry. The blast furnaces of the Dominion Foundries and Steel Company, Tofasco, burned around the clock, 7 days a week, casting armor plate and weapons components for a war that was consuming steel faster than any conflict in human history. The glow of molten metal lit the Lake Ontario shoreline at night. The hammering of forge presses shook the streets at all hours. And in the engineering offices above the factory floor, some of Canada's most gifted mechanical minds were being handed a problem that had no existing solution. The brief was simple to state and extraordinarily difficult to execute. Take the M4A1 Sherman, already being produced in Canada under the designation Grizzly at the Montreal Locomotive Works, and transform it into an anti-aircraft platform capable of tracking and destroying a fast-moving aircraft in a firing window of under 4 seconds. 4 seconds. The entire design of the Skink was built around that number. At those engagement ranges and speeds, a single cannon, even a fast-firing one, was a lottery. The solution the Canadian engineers arrived at was characteristically direct. If one barrel wasn't enough, use 4. The Skink's turret would be armed with 4 20mm Polsten cannons arranged in 2 pairs, their barrels clustered tightly together and fed by drum magazines. The Polsten was itself a marvel of wartime engineering, a simplified, faster-to-produce variant of the Swiss Oerlikon cannon, redesigned by Polish engineers who had fled to Britain after the fall of Warsaw. It commonly fired 20mm high-explosive incendiary ammunition at roughly 450 rounds per minute per barrel. 4 of them, firing in concert, produced a combined cyclic rate of roughly 1,800 rounds per minute, a figure that sounds less like anti-aircraft artillery and more like a force of nature. But the guns were only half the problem. An aircraft crossing at 300 miles per hour doesn't wait for a gunner to catch up. The turret carrying those 4 barrels had to be able to move, faster than anything comparable on the Allied side. The hydraulic traverse system designed for the Skink turret was a bespoke Canadian engineering solution, purpose-built for this vehicle and no other. Reported performance indicated the Skink's turret could rotate substantially faster than that of a standard Sherman, allowing a trained crew to track and lead fast-moving aircraft far more effectively. This required the Grizzly's hull to be significantly modified. The engine deck was reworked to accommodate the demands of the hydraulic power system. The turret ring, the circular track on which the turret rotated, was enlarged and reinforced to handle the stresses of such rapid movement under the weight of the new superstructure. Canadian engineers and foundry specialists solved the casting challenges of the turret itself, producing a unit of complex geometry that had to be both proof against small arms fire and light enough to be spun at that remarkable speed. The elevation system matched the traverse in ambition. The cannons could depress to near horizontal, a detail that would prove more significant than anyone planned, and elevate steeply enough to engage aircraft passing almost directly overhead. The entire gun assembly moved fluidly, controlled by a gunner whose seat was integrated into the turret and moved with it, keeping his sightline consistent regardless of turret position. The Skink prototype underwent testing from late 1943 into 1944. The results were, by the accounts of the engineers and military observers present, extraordinary. In tracking trials against towed target drogues simulating aircraft, the combination of traverse speed, rate of fire, and 20mm explosive payload impressed the engineers and military observers who evaluated it. The trials demonstrated that the Skink combined heavy protection, exceptional turret speed, and concentrated firepower in a way few Allied armoured anti-aircraft vehicles could match. 3 complete Skink vehicles were ultimately built. Britain, recognizing what the Canadians had built, subsequently ordered 130 Skink turrets to be mounted on their own Shermans. The production lines were being prepared. The war was waiting. And then the sky went quiet. By the summer of 1944, the Luftwaffe was dying. It had not happened suddenly. It had been a slow, systematic destruction, the product of American long-range escort fighters, relentless strategic bombing of German fuel refineries and aircraft factories, and attrition that the Reich simply could no longer replace. The pilots who had terrorized Allied columns in 1941 and 1942 were dead, captured, or flying obsolete aircraft on a fraction of the fuel they needed. Long-range Allied fighter escorts, particularly the P-51 Mustang, had made the skies over Europe increasingly hostile to German aircraft, and by the time the Allied armies broke out of Normandy in August 1944 and began racing across France, air superiority was no longer a goal. It was a given. For the front-line Canadian infantry, this was the best possible news. For the engineers who had spent 18 months perfecting the Skink, it was a quiet catastrophe. The mathematics of the situation were merciless. The Skink had been designed to solve a specific, urgent problem: the threat of Luftwaffe ground attack aircraft operating freely over the battlefield. By late 1944, that problem had been effectively eliminated. German fighters and Stukas were appearing over Allied positions with decreasing frequency, and when they did appear, they were operating in small numbers, briefly, under extreme risk. The elaborate, expensive infrastructure of the Skink program, the modified Grizzly hulls, the DeFasco cast turrets, the hydraulic systems, the Polsten cannons, the training pipelines, had all been built to counter an enemy that was, for all practical purposes, already beaten in the air. The Canadian Army Technical Development Board faced a decision that had no good answer. Continuing full production of the Skink meant committing significant industrial resources that were not unlimited, even in Canada's remarkable wartime economy, to a vehicle whose primary purpose had evaporated. The 130 turrets Britain had ordered were quietly reconsidered. The production contracts were reviewed, and in the brutal calculus of wartime procurement, where need always had to outweigh elegance, the conclusion was unavoidable. The Skink program was cancelled. It is worth sitting with that for a moment, because what was cancelled was not a failed experiment or a flawed design. The Skink had performed successfully throughout its testing program. It met or exceeded expectations during the trials conducted. The engineers who built it had produced something genuinely world-class, and the military officers who evaluated it knew it. The cancellation wasn't a rejection of the Skink. It was a verdict delivered by history itself, a declaration that the war had moved on, and the Skink, through no fault of its own, had been perfected at precisely the wrong moment. Only 3 complete vehicles were ever finished. 3 Skinks in a war that had consumed millions of tanks, half-tracks, armoured cars and self-propelled guns across 6 years of global conflict. 3 machines representing the full industrial capability of Canadian wartime engineering, sitting in a depot as the front lines pushed deeper into Germany, their 4 barrels pointing at a sky that held no targets. But quietly was not the same as forgotten, because someone, looking at those 3 completed vehicles and their extraordinary firepower, had a different idea entirely. If the sky held no targets, perhaps the answer was simply to point the barrels somewhere else. In the early weeks of 1945, one of the 3 completed Skinks was loaded onto a transport and shipped to northwest Europe for field evaluation with the 1st Canadian Army. The official purpose was still nominally anti-aircraft. The paperwork said trials. The Army still held some institutional hope that the Luftwaffe might yet stage a meaningful resurgence. The Germans had, after all, launched Operation Bodenplatte on New Year's Day 1945, a mass air attack that had briefly, painfully reminded the Allies that the Luftwaffe was wounded but not entirely dead. On paper, the Skink's deployment made sense as a precaution. The men who received it had other ideas. The 1st Canadian Army in early 1945 was fighting through some of the most brutal urban and rural combat of the entire Northwest European campaign. Operation Veritable, the grinding Allied push through the Reichswald forest and into the Rhine approaches, had turned the landscape into a nightmare of flooded fields, dense tree lines, fortified farmhouses, and towns where every building had been converted into a defensive position by Wehrmacht and SS troops, who knew the war was lost and intended to make the Allies pay for every meter of German soil regardless. Snipers fired from church towers. Machine gun teams held crossroads from the upper floors of shattered houses. Mortar teams sheltered behind stone walls that standard tank rounds punched through too slowly, too imprecisely to neutralize quickly enough. Into this environment, the Skink arrived. The Canadian troops who first directed it against a ground target were, in all likelihood, motivated by simple pragmatism. Here was a vehicle with 4 rapid-fire 20mm cannons mounted in a turret whose reported traverse speed approached 60 degrees per second, while also being able to depress to near horizontal. The enemy was in that building. The math was not complicated. What followed was not a battle. It was a demonstration. The 20mm Polsten round had been designed to destroy aircraft, thin-skinned, fast-moving targets where explosive effect and incendiary payload mattered more than raw penetration. Against buildings, that same combination of high explosive and incendiary effect was catastrophic. Brick walls that might absorb a rifle bullet or deflect a grenade fragment offered limited protection against sustained bursts of 20mm fire. Timber floors collapsed. Roof structures ignited. Stone facings shattered and fell. And because the Skink's turret could traverse and elevate with such extraordinary speed, the gunner could systematically walk fire across a building's face. Upper windows, ground floor, corner positions, faster than defenders could relocate. The volume of fire was, by any account, psychologically overwhelming. A standard Sherman's main gun fired once, reloaded, fired again. There was a rhythm to it, a cadence that experienced German infantry had learned to work around, using the seconds between shots to move, to reposition, to survive. The Skink had no such rhythm. It offered no pause to exploit, no gap in which to run. Nearly 1,800 rounds per minute of high-explosive incendiary fire is not a rhythm. It is a sustained, unbroken catastrophe, a sound less like gunfire and more like industrial machinery tearing itself apart at full speed, directly in front of the men on the receiving end. During its operational deployment, German defenders made rational decisions. Positions that might have held against infantry assault or standard tank fire were abandoned. Troops who had orders to hold to the last round reconsidered those orders when 4 barrels swung toward their trench line. No cover available to a rifle section, a machine gun team, or a mortar crew in a Dutch town in 1945 could survive what the Skink delivered in a 3-second burst. The choice between dying in place and surrendering became, in the presence of those 4 rotating barrels, very simple. There are no precise, documented casualty figures attributed to the single Skink that operated in the Netherlands. The record-keeping of a war in its final brutal months was not meticulous, but the accounts that survive from Canadian veterans and operational reports are consistent on one point. The Skink, designed for the sky and repurposed for the ground, was devastatingly effective. More importantly, it reduced the danger faced by Canadian soldiers who would otherwise have been sent into defended buildings on foot, armed only with rifles and grenades. The war in Europe ended in May 1945. The Skink fired its last rounds, at the ground, not the sky, and was brought back from the front. It had spent its entire operational life doing a job it was never designed to do. The Skink takes its name from Ontario's only native lizard, a small, secretive creature that spends most of its life unseen, existing in such limited numbers that many Canadians have never encountered one in the wild. It is fast, remarkably capable for its size, and extraordinarily rare. The engineers who chose that name may not have known how perfectly it would fit. All of them poured their skill into a weapon that the changing shape of the war rendered obsolete before it could be produced in meaningful numbers, and yet it was not wasted. One vehicle proved that the engineering was highly effective. It saved lives. It broke positions that would have cost Canadian infantry dearly to take any other way. The Skink is not remembered the way the Sherman is remembered, or the Churchill, or the Tiger. It exists in the documentary record as a footnote, a brilliant solution to a problem that was solved by other means before the solution could be fully deployed. But for the Canadian soldiers who watched those 4 barrels traverse and fire in the last months of the war's most brutal campaign, it was not a footnote. It was the sound of survival. It was Canada's engineering capability made real, made steel, made lethal, arriving just in time to matter, even if the world never fully noticed. Some weapons win wars. Some weapons simply bring men home. The Skink did the harder thing.